Hello once again, everyone. Today we're going to talk about quadrilaterals, and here you can see the hierarchy of quadrilaterals that will be part of our discussion. So, when you talk about quadrilaterals, take note that these are polygons that, well, has four sides. Okay, so any polygon for that matter that would be having four sides is generally known as a quadrilateral, and you have the following. So the basic and the major types are, we have the first one, the kite, the parallelogram, and the trapezoid. And here, as you can see below, you have examples like isosceles trapezoid, rectangle, rhombus, and square. They are the special types of quadrilaterals which are based from the major types kite, parallelogram, and trapezoid. And we will deal with them, each one of them, in this discussion today. So first, let's answer the question, what is the sum of all the angles in a quadrilateral? Now, as you can see in the figure, to prove if what's the sum of all the angles in a quadrilateral, you need to bisect, or not necessarily divide it into two parts. You just have to create a triangle. So you have here quadrilateral S R U T. So when you name a quadrilateral, you use four letters and it should be consecutive. So S R U T. You can say S R T U. That's wrong. So it should be consecutive. Any way you do it, as long as it's consecutive. Now, it's a quadrilateral, and if you notice, I have here TR, which we call our diagonal. And looking at the figure, when we draw our TR, we notice that we have formed two triangles. And before this discussion, before this topic, we've learned that in a triangle, the sum of all the measures of the angles is equal to 180 degrees. And so with that thought, we can surmise that in a quadrilateral, the sum of all the angles would be 360 degrees, because basically you can make two triangles out of a quadrilateral, so which means that the sum is 360 degrees. Another reason that we can talk about is a quadrilateral can also be formed if you have two pairs of parallel sides. And since we learned already the properties of parallel lines and transversals, let me take you to the second figure here. So here, you can see that this side is parallel to that side, given the arrows. And this side is also parallel to this side. Now, since we've learned about parallel lines and transversals, we know that 135 degrees and 45 degrees here are what we call our same side interior angles. And for this to be parallel, these two lines here, this should add up to 180 degrees, or they should be supplementary for that matter. Also, on this side, 45 and 135 should be equal to 180 degrees, because same thing, they are same side interior. Same can be said about this side here. If this is parallel to this, 45 here and 135 should also be same side interior. Now, basically, that's just the same with the other parts or the other angles if we want to prove them parallel. And so, what we can see here, we actually have formed a quadrilateral because the parallel sides form the four sides of our quadrilateral. And if you're going to add up all the angles here, you will end up having 360 degrees. So we settle it now. When you talk about the sum of all the angles of a quadrilateral, it will always be 360 degrees. So let's have, for example, this. how do you make the following quadrilaterals, or I mean figures, a quadrilateral? So here, you're given three angles, and you have to solve for the fourth one. You can pause this video and solve for the value of x. So since we know that all the angles here, if this is to be a quadrilateral, should add up to 360, we can actually form an equation that says 360 should equal to 110 plus 92 plus 88 plus x. And we can solve for x. So this is 360. So 110 plus 92 is going to be, let me have that, 202 plus 88 plus x. To continue, we have 290 plus x should be 360 here. Transposing this to the other side, we have 360 minus 290 equals x. So x is equal to 70 degrees. So the value of x here is 70 degrees. So let's just counter check. 110 plus 70 is going to be 180, and 92 plus 88 is also 180, and the total of that is 360. Continue. What about this one? Still the same. If we are to make this a quadrilateral, we need to make sure that all the angles will equal to 360. So equation is still the same. 360 is equal to 80 plus 70 plus x plus 2x. Continuing that, you have 360. That would be 150 plus 3x. So this will be 360 minus 150 equals 3x. So what do you have here? This is 0, 1, 2 equals 3. Divide by 3 on both sides. Therefore, you have 70. But 70 is just the value of x. But here, you can write already 70 degrees. What about 2x? So if you want to find 2x, that would be 2 times 70, which is 140 degrees. Double check. 80 plus 70 is 150. Plus 140 becomes 290. And addition of 70 is 360. So all the sides would equal to 360, which means we're correct. Now, in this figure, you can see some exterior angles drawn, and you also see some angles in the interior of the quadrilateral. Same property is actually involved when we talked about properties of exterior angles in a triangle. Notice that still we have a straight path, and because we have an exterior angle here, this will form what we call a linear pair to the interior angle adjacent to it. So let's say we start with 68 degrees. So 68 degrees is right here, and this is your interior angle adjacent to that, which is angle BAC. That's angle BAC. So we first find the measure of angle BAC so that we can slowly but surely complete the parts of our quadrilateral in terms of its angle. So since we know that these two are linear pairs, so the formula for that would be 180 minus 68 degrees, which will become, this will be 2, this will be 1, 112. So this would be 112. That's angle BAC. Now take note that this symbol here means that that is a right angle. So that's 90 degrees. Now we are left with this angle here. That's the measure of angle B D or BDC or CDB. So we're looking for that one. And once again, we know that it forms a linear pair with the angle y plus 48 degrees. So how do we do that? Since it's linear pair, it could be 180 minus y plus 48. And if you want to further simplify this, you have to distribute the negative sign. This will be 180 minus y minus 48. But still, we can simplify this into 180, or sorry, 180 minus 48. We can just get the difference for that. So that's 132 minus y. That's the measure of this angle. 132 minus y. That's angle BDC. Now that we know all the parts of the interior angles, or all the measures, I mean, of the interior angles, then we can go back to our equation. 360 equals 2y plus 112 plus 90 plus 132 minus y equals 360, and that would be our equation. So simplifying other terms, we have 2y and a minus y here. That would just simply be y. 112 plus 90 and plus 132. So let me grab this portion here to add to show you what's the sum. So that's going to be 4, 13, 1, that's 334, and that's positive. So plus 334. And then 360 minus 334 equals y. So y here is equal to 26. Alright, so since we know what the value of y is, then we look for those angles in our quadrilateral that we need to substitute y to. So like for 2y, if y is 26, this angle right here becomes 52 degrees. 2 times 26. What about the exterior angle here? We can also solve that. Since y is 26, we add 48 to it. This becomes 74 degrees. But we also have something here inside, 132 minus y. And if we're going to solve for that, 132 minus 26 becomes 106 degrees. Now, take note that 106 should be supplementary or linear pair to 74, which by inspection is yes, it's supplementary. And I leave you the checking whether it's 360 or not. Let's proceed now to the next type of, or to the first type of quadrilateral. We will discuss trapezoids. When you talk about trapezoid, this is a quadrilateral with only one pair of parallel sides. And this parallel sides that we talk about, we call it the base. Okay, so in the figure, you can see that you have B1 and B2. These two are understood to be parallel. You also have another part here which we call the height, or it's a segment that forms an altitude or a right angle to the opposite side. We also have legs of our trapezoids. These are the parts where they are not parallel. So legs of a trapezoid will always intersect. Now, in a case where the legs are congruent, it's a special kind of trapezoid which we call isosceles trapezoid. So let me just write it down. We have what we call an isosceles trapezoid. This is a kind of trapezoid wherein the legs are congruent. So take note of that. Alright, so let's try to see if we can solve some problems regarding trapezoid. Now, let me just emphasize that when we talk about bases which are parallel, our concept, knowledge, and skill about parallel lines and transversals will actually apply. So, special angles that we've talked about on parallel lines and transversals will also be used. So, let's proceed to the first example. Example number 1. Here, you can see the arrow to indicate that they are parallel. And you can see tick marks as well on trapezoid TRAP. So you have trapezoid TRAP. Once again, when you name it, it should be consecutive. Okay. So the tick marks tell us that these two legs are congruent. So what kind of trapezoid is this? Alright, you're correct. This is what we call an isosceles trapezoid. Okay, so if this is 115 degrees, and these two sides here are actually parallel, this side, TP, becomes its transversal. So that would mean 115 degrees and this angle here are same side interior angle, and they are supplementary. So first, we write here the angles that we need to measure. So another angle here, it's angle TPA. So I'm referring to this angle. Let me name this angle 1, and it's equal to angle TPA. So this is angle 1. 115 and angle 1 are supposed to be supplementary. So what would be the measure of angle 1? That would be 180 minus 115, which is 65 degrees. So here, angle TPA is 65 degrees. Let's go now to the second angle. Measure of angle TRA. And let's, for example, name that angle 2. So this is angle 2. What would be its measurement? Again, if this two lines here are parallel, therefore this 215 and 65 should be supplementary. What about if you have angle 2? Now, let's find, or let's ask the help of our parallel lines. So if these are parallel, again, this one would actually become its transversal. But in this case, the angle that we're supposed to relate it to should be this angle, which is in this case our angle 4, or that would be measure of angle PAR. Sorry, it's angle 3. Okay, so what do you think would be the measure of angle 2? Alright, since we cannot draw a relationship on the in what do you call this one, parallel lines and transversal, let's draw its relationship from the tick marks. The tick marks actually tell us that there are angles there that would be congruent. And before, we've learned that in isosceles triangles, if there are two sides that are congruent, our base angles become congruent as well. So here, it's the same thing. So if this is your congruent side and this one, your bases here would actually be equal. So angle 1 and angle 3 would be of the same measure. So this would also be 65 degrees. Angle 115 and angle 2 would also be of the same measure, and that would also be 115 degrees. Alright? That is what the tick mark would tell us. But this is only in the case of isosceles trapezoids. Now, to prove if our answers are correct, we know that this is the transversal if these two lines here are parallel. So 115 and 65 actually also forms what we call same side interior. And if you're going to add that up, that would also be equal to 180 degrees. So angle 2 is 115 degrees and this is 65. So one property here that we can tell about isosceles trapezoids, is that there are two congruent angles, which are actually base angles. How do you know they're base angles? Because they're located on the bases. Okay, so we can say that the base angles of an isosceles trapezoid are congruent. Okay, let's proceed to the next example. What about this one? It's still another isosceles trapezoid. You're right, because of our tick marks right here. And so we learned that our values or base angles are just congruent. So this would also be 64 degrees here. That's angle A. Now, 64 degrees and this angle are supplementary because they are same side interior. So that would mean if I want to find the measure of angle R, I need to add 64 and 4 times 3y plus 2, and that would equal to 180. So 64, this will be distributed, so be careful with that. And this will be 8 equals 180. So to continue, this would be 12y plus 72 equals 180. So we have 12y here, 180 minus 72. So continuing the value, we have 12y equals 102 or 108. I'm sorry, that's 108. Is that even divisible by 12? Let's see. So 108 divided by 12. So what do we need to multiply to 12 for 100 to be closer to 108? Okay, let's try maybe 9. So 12 times 9, this is 18, carry 1, and that's 10. So dividing this by 12, we have y equals to 9. But that's just the value of y. What is the measure of angle R? So even before we have set out for this, we actually know the measure of angle R already. Because if this was 64, we simply subtract that to 180 degrees. So 180 minus 64, this would be 6, this would be 1, and that's 116. This should have been 116 degrees already. For those of you who have noticed it, we need not actually solve this via algebra, but then we simply follow the procedure. Now, this is another way of counter-checking if our answer is correct. Is 12y plus 8, right here, this is 12y plus 8 equal to 116 degrees. So let us see. So this will be 12 times 9 plus 8 because you distribute this inside. So 12 times 9 is 108 plus 8 becomes 116. So we are correct. Now, if you'd ask me which of the processes do I need to use, it would actually depend upon you. Which is your perspective? Do you see that you need to add this angle and 64 and come up with 180? Or do you just simply equate this angle to 116 because you know that it's just equal to 116 using the formula. So it depends upon how you see things. Nevertheless, you can still arrive with the correct answer. And the last example on trapezoid is this one. Let's say I want you to find the measure of angle A. Also, I want you to find the measure of angle D and the measure of angle E. Now, how are you going to do that? Using the trapezoid that you can see below. Do you see the trapezoid here? It's trapezoid B, C, E, D. Okay. So, first, we have to make use of the parallel lines and transversals. So, for me to find angle D, I simply refer to 40 degrees because I know that if these two are parallel, you can see a transversal there. So, this angle, 40 degrees, is actually the corresponding angle of angle D. So, this is also 40 degrees. Alright, so check your work if you're correct. And if you want to find angle A, that is actually basically the same. That would be 110 here, and angle E are your same side interior. So this would also be 70 degrees. Alright, so angle E is 70 degrees. So I hope you can see now how important is the topic on parallel lines and transversals that we did a few weeks ago. Now, last angle, we're looking for angle A, and we are actually looking at now the triangle ADE. And to solve for angle A, we go back to the definition of the angles of a triangle that says the sum is equal to 180. And we know already that we have 40 and 70. And if you add that, that would equal to 110. Therefore, this angle here is 70 degrees. Alright. So we're done. And if we're going to check all of it, it's going to be 180 degrees. Okay, next we will talk about what you call parallelograms. And if for trapezoids, we have two sides that are parallel, which we call the base. For parallelograms, we have two pairs of parallel sides. And these sides, to be parallel, they should be opposite sides. So two pairs of parallel sides, which are, of course, opposite. And here in this figure, we have parallelogram. I'm going to name that as BADC. Again, it should be consecutive. You can see here that there are tick marks, and this will actually form the different properties of the parallelogram. So tick mark here and tick mark here. These two sides are parallel, but at the same time, they are congruent. So it's the first property of parallelograms that you should remember, that the opposite sides, which are at the same time parallel sides, are congruent. The same thing here. These two sides are parallel, but they are also congruent. So that's the first property. Second property, let's go to the angles inside the parallelogram. You see as well that there are equal angles here. So this angle and this angle are your opposite angles. Also this one and this one. And what have you observed? Correct, that they are also congruent. So let me erase this first. Let's try to jot down, or you can write it down in your own notes, what are the different properties. So first property of a parallelogram, that the opposite sides are congruent. Also, you can say opposite angles are congruent. Now, what about the consecutive angles of a parallelogram? Let's try and see. When you talk about consecutive, these angles lie on an included side. So like for example, angle C and angle B, what relationship can you form? Correct. They are actually on the same side interior of two parallel lines and transversal. Therefore, they are correct. Supplementary. So here you can say consecutive angles are supplementary. And the last, is on diagonals. So the last is, what have you noticed about its diagonal? So when we draw the diagonals, which there are two, by the way, of a parallelogram, or for any quadrilateral for that matter, there are two diagonals. You can see here that there are tick marks formed. So for the diagonal BD, the side, this part and this part where we intersect are just equal. Also, this part and this part, which means to say that the diagonals of a parallelogram bisect each other. Okay, so when they intersect, they form two smaller segments which are actually congruent. So these are the general properties of parallelograms. Now on the right, you can see there are special parallelograms, and all of these special parallelograms here, this one we call the rhombus, this one is a rectangle, and this one is a square. All of these special parallelograms have their own unique property on top or in addition to the properties of parallelograms. Let's try rhombus. When you see the rhombus here, the first property that you can tell is that all its sides are congruent. That's the first property that we can take note. And that is in addition to the first four properties of the parallelogram. So that would mean rhombus as well would follow the other four properties of a parallelogram. Okay? The second one that we can see is that the diagonals of a rhombus are perpendicular because of the right angle that is formed. So these two are the special unique property of the rhombus. What about rectangle? So for rectangle here, you can see that all angles are right angles. It's the first one. Now, it's not drawn there, but actually diagonals of a rectangle are congruent. Alright? That's the second property, special property of a rectangle. So once again, these are special properties on or in addition to the properties, the basic properties of parallelograms. Now, is it possible for a rectangle to have diagonals perpendicular just like a rhombus? The answer is no. Is it possible for a rectangle to have all of its sides congruent? The answer is no, because that is only for rhombus. But there is a quadrilateral that would have or would take all of these properties, and we have the square. So the square is actually born out of all the properties of the parallelograms, all the properties of the rhombus, and all the properties of the rectangle. So you can say that for a square, it is a quadrilateral, that all sides are congruent, check. All angles are right, check. All the diagonals are also perpendicular, at the same time congruent. So that is a square, and we know that this is a regular polygon in addition to its all of its properties. Alright? So in our quiz, in assessment number 4, the answer to, if you're going to say 4 sides regular polygon, you should really say square. You cannot just say quadrilateral. Alright? So let's try and see if we can solve some parallelograms. Here you have the instruction. find the value of the variable so that the given quadrilaterals are parallelograms. Okay. By the way, this is a long video, and if you want to take a rest from time to time because of the overload of the information, please do so. You are allowed to take breaks while watching this video because it's actually a little long. So, let me continue. For this to be a parallelogram, what should be equal? What angle should be equal? Because you can see the given are angles. So here I can just actually say that this angle here, because I know what it is and how much does it measure, this is congruent to this angle based on the property of angles in a parallelogram, which the opposite angles are actually congruent. So in total, these two angles becomes 115 degrees, which means to say this angle here is also 115 degrees. Angle FED, 115. Now, what is the significance of that? If I know the opposite angles, I can solve the consecutive angles using the property that says consecutive angles are supplementary. So if you want to solve the measure of angle D, 5y degrees, you can simply pair it off with 115 degrees and establish their relationship, that they are supplementary because they are consecutive angles. So 5y plus 115 is simply equal to 180. Alright? So 5y is equal to 65 because I have to transpose this and that will subtract. So divide by 5, y becomes 13. That's the value of y. Or, simply put, this angle is simply 65 degrees. Correct? Because they are supplementary on the consecutive part. But of course, we have to find the value of y. So we still have to solve. Now, what about 7x minus 5? Do I need to add it up to 115? Or could I just simply say 7x is equal to 65? Well, that depends. Again, you can have it added to 115 and then equal to 180. Or you can take the shorter route, just equate it to 65 because we know that this angle and this angle are congruent because they're opposite angles of a parallelogram. So here 7x would be 70 because this is plus 5 and x is equal to 10. Do I need to solve for 7x minus 5 in terms of the value of x? The answer is no. This is actually 65 degrees. But still, the instruction tells us that we have to find the value of the variables, therefore x should be solved. Let's go to the next. This time we deal with sides, and it's just the same thing actually. These sides of a parallelogram are equal. We're talking about opposite sides. So let's get right on to the equation. So this is 6x minus 7, and that's just equal to 2x plus 9. So if you're going to solve that, you have 6x, and I'm going to put 2x here, and 9 plus 7 is on the other side. So 4x equals 16, and x is equal to 4. So therefore, the measure of 2x plus 9 is 2 times 4, 8, plus 9 is 17 units. What about 6x minus 7? So 6 times 4, 24, minus 7 is also 17 units. Which is not surprising because they are opposite sides. And they should be congruent. And the last, we have to solve y plus 3 equal to 12. We know that this is 12. That should be 12. But what is the value of y then? So, of course, algebra tells us that y is 9. Okay. Next, we have this one. And this is the last. Congratulations for finishing this video. So here it's a combination of angle and sides. And in the given 105 is the opposite of d minus 21. And we know that the relationship is that they are congruent. Opposite angles are congruent. So simply saying what the value of d is 126. Okay, but you don't put degrees. It's the value of d. We know that this is already 105. But we're just trying to prove, or just trying to tell ourselves that what should be d for this two to be exhibiting a parallelogram figure. What about 20 and z minus 8? For this figure to be a parallelogram, the value of z should be 28. Alright? So I've wrapped up pretty much all the kinds of quadrilaterals, and I hope that you've learned something from this. We only have 1 week left of regular class, and we will still discuss quadrilaterals and polygons. But hopefully, through this long video, you can already synthesize the lesson for the following week. So there will be an activity in class regarding this one. So I hope you enjoyed the video, you learned about quadrilaterals from this video, and I hope that you could actively engage yourselves with the activity that we're going to have tomorrow. So once again, thank you and goodbye.